Hello students, good morning. How are you feeling now? You must have come with very happiness after celebrating the Diwali holidays. Am I right? Fine. Today we will see the rigid pavements. The pavements which possesses flexural strength are called as rigid pavements. Whereas in case of flexible pavement, flexural stress is almost negligible. The rigid pavements are generally made of Portland cement concrete and sometimes called as CC pavements. The cement concrete used for rigid pavements is called as pavement quality concrete (PQC). The CC pavement slabs made of PQC are generally expected to sustain up to 45 kg per centimeter squared of flexural stresses. The rigid or CC pavements are designed and constructed for a design life of 30 years. In fact, theoretically, if you see any literature, it can be designed up to a span of 50 to 60 years. You can see the rigid pavement. Whatever the bars which are protruded here, they are meant for connecting the two slabs which are running in the longitudinal direction. They are known as dual bars. Dual bars. D-O-W-E-L. Dual bars. These are used just to connect the two slabs so that whenever the load is applied here, that will be transferred uniformly and uniquely and effectively on both the slabs. That's all. Where rigid pavement needed? Rigid pavements are usually provided under the following circumstances: where very heavy rainfall is observed, poor soil conditions, poor drainage, extreme climatic conditions. Combination of some of these conditions which may lead to development of cracks in the pavements, we go for rigid pavements. Structure of rigid pavement: even without base or subbase, directly over the soil subgrade, the cement concrete slab may be casted. Components of rigid pavement: soil subgrade, granular subbase course, base course, CC or PQC pavement slab. Usually we avoid out of these two, any one is avoided. So if base course is not provided, only granular subbase course. The subgrade soil of rigid pavements consists of natural or selected soil from identified locations fulfilling the specified requirements. It should contain required density and other engineering properties. You are all aware of these. Subgrade ultimately supports all the layers of rigid pavements and traffic loads which is coming over the pavement. The compressive stress transmitting to subgrade layer are very, very low. No need to consider allowable vertical strains. The strength of soil subgrade is generally evaluated by adopting the plate load test. We have explained and we have learned about plate load test in detail. Okay, the load supporting capacity of the subgrade is assessed in terms of modulus of subgrade reaction K. Modulus of subgrade reaction K may be defined as the pressure sustained per unit deformation of subgrade at specified deformation or penetration using specified plate size, that is maximum 75 cm, minimum 30 cm diameter. Maximum is 75 cm dia. But for highway pavements, plate of 30 cm, as I have pointed out here, is used. Granular sub and drainage layer, all these are being covered already. Drainage layer also is covered already. Base course. The granular base course is generally provided under the CC pavement slab. Base course provided in low volume roads and in roads with moderate traffic. Roads carrying heavy to very heavy traffic loads, high quality base course material is required. Dry-lean concrete, dry-lean cement concrete or dry-lean concrete layer provides a uniform support with high value of K, that is modulus of subgrade reaction, an excellent working platform for laying PQC. This is the platform which is used. PQC pavement slab M40 cement concrete mix with a minimum flexural strength of 45 kg per centimeter squared is to be used. The cement concrete pavement slab should withstand the flexural stress caused by heavy traffic loads and warping effects due to temperature, that is bending stress. The pavement will be bent. The pavement will be bent, showing concave downward or concave upward. Concave upward, depending upon where the temperature is high. Especially in the midday, temperature will be high at top layer, whereas in the midnight at lower layer. There, suppose this is the thickness. Here the temperature will be maximum, T maximum, in the midday, whereas T maximum will be at midnight because of transformation of temperature from the top layer to the bottommost layer of the cement concrete slab is taking place, spreading over the total duration from midday to midnight. Depending upon the temperature gradient, the temperature transformed, and thereby this top layer become cool and bottom layer will become hot in the midnight. Okay. And these are the different layers. Once again it is shown separately, simply copy pasted, nothing else. You yourself can download from internet and you can see any number and any type of such payments having or consisting of different layers in different part of our country. Basic components of a cement concrete pavement. Basic components are all shown. You yourself can zoom it and read everything and can understand on your own. Little effort you also should put because you are becoming engineers in short duration. Just in 6 to 8 months you will become an engineer. So, joints in rigid pavement. Joints are very important components in cement concrete pavements and they have important functions to be performed. Main purpose of joint is to relieve part of the stresses developed due to the temperature variation in the slabs and also load stresses. The joints in cement concrete pavements are longitudinal joints and transverse joints. This is longitudinal joint, this is transverse joint. Longitudinal joints, you can see in pavements of width 4.5 meter, there is a need to provide a longitudinal joint. The need of these longitudinal joints is to prevent the shrinkage cracks happening during the initial period of curing. However, as the lane width is generally 3.5 meter to 3.75 meter, longitudinal joints provided between each traffic lane. Shrinkage cracks develop in slabs whose width or length is more than 4.5 to 5 meter. The bars are provided along the longitudinal joints in order to prevent opening up of the longitudinal joints in the due course of time. These tie bars of specified diameter and length are embedded at the specified spacing at the mid depth of the pavement slab. How that they are placed and spread is shown in this photograph. The longitudinal joints functions as contraction joints and pavement development and additional shrinkage cracks in the longitudinal directions. Warping joints relieve part of warping stresses. Lane markings in highways with 2 or more lanes markings. Transverse joints are subdivided into 3 categories: contraction joint, expansion joint, and construction joints. You can see here the transverse joint. Contraction joints are formed by cutting grooves across the pavement slab at regular intervals. Width of grooves not less than 3 mm. Remember, 3 mm or 0.3 centimeter. Depth of grooves 25 to 30% of the pavement thickness. Whatever the thickness, in that 25 to 30% is allowed for depth of grooves. Spacing of 2 contraction joints 4 to 5 meter. The shrinkage cracks formed below the each groove at the weakened section during the initial period of curing. Anyhow, shrinkage cracks formed at regular intervals. To prevent those cracks, contraction joints are provided. Why contraction joints are provided? In order to prevent the formation of shrinkage cracks. Anyhow, shrinkage cracks developed along these predetermined sections only. In order to prevent widening of these fine shrinkage cracks, steel reinforcement may be provided across the contraction joints. If no reinforcement provided across the contraction joints, such as the pavement is plain jointed concrete pavement, closely spaced contraction joints help to relieve part of the warping stresses developed. Expansion joints. Cement concrete. See how beautifully the joint is sealed using machineries. Equipments and machineries are deployed in order to seal these joints. These are the joints are sealed with the bituminous material or any flexible material which is suitable for the temperature conditions, environmental or climatic conditions. To accommodate these variations in length, expansion joints are provided in transverse pavement at long intervals. The expansion joints are formed as through joints across the full depth of the slab with about 20 mm gap between the two slabs, 2 cm about. The expansion joints provided after a number of contraction joints. The cement concrete pavement slab is separated across the expansion joint. Therefore, there is no load transfer across the expansion joint. Weak cross section of the cement concrete pavement. In order to strengthen these sections and to provide load transfer across the expansion joint, suitable dowel bars, I already told, DOWEL, dowel bars, are installed during construction. You see, while construction is going on, this photograph reflects construction joints formed due to gaps between the continuous construction works. During the construction of CC pavements, when the concreting work is stopped at the end of the day, the concrete paving is suspended, the construction joint is formed. That is known as construction joint. Okay. When the work is stopped, next day it is to be continued. That means joint is to be formed between the two new casting of different slabs in 2 different days. Construction joints formed across the pavement about full depth. It is necessary to provide dowel bars across these joints for load transformation. Nothing else. It is not like structural frame buildings, like single-story, multi-story buildings. It is just to transfer the load on 2 different casted slabs. Dowel bars are provided. It is better to make a construction joint as expansion joint or contraction joint if possible. So components of rigid pavement, once again it is shown. Factors affecting the rigid pavement: wheel load, temperature variations at the location of the road, types of joints and their spacing, subgrade and other supporting layers. Factors affecting the design. The two major factors primarily to be considered for the design of rigid pavement are heavy traffic load and temperature variation between top and bottom of the cement concrete slab, as I have already shown. Mid T maximum will be at mid-day. Here it is transferred and the T maximum will be in the midnight after transferred from top to bottom of the total thickness of the slab. Say small HH may be 20 to 25 centimeters. Okay. The other factors which affect the design and performance of the rigid pavement are, these are the basic primary factors. Temperature stresses due to expansion and contraction of rigid pavement during summer and winter. Volumetric changes in subgrade due to changes in moisture and temperature, especially when there is rainfall in that location. Naturally the subgrade soil will get expanded. Because of that some changes takes place. Loss of subgrade support due to some reasons at some locations, not at all locations, but at some locations this could be possible. Wheel load, this we have already covered. Magnitude of the load, P kg. Contact pressure, kg per centimeter squared. Contact area, depending upon the radius of the circular plate, which is assumed that load is transformed from the top of the pavement. Assume that wheel loads act on circular contacted area. Location of load application on slab. There are three locations, since it has length, width and thickness. Accordingly, the load application also will be interior. Suppose if this is the slab, this is interior region, this is corner region, this is edge region. Okay, edge region. This is corner region. This is interior region. Okay. Okay. Interior load applied at a location away from the edges of the slab. Corner load applied at the corner region of the slab. Edge load applied at the edge region of the slab. The magnitude of stress due to a given wheel load applied at the corner region is the highest in comparison to the stresses due to the same load applied at the edge or interior region of a cement concrete pavement. So it has been observed, Goldbeck, by the engineer Goldbeck has identified that the maximum stress developed at the corner and failure also usually takes place from corner itself, rather edges and interior. The load stress applied at the interior region of a cement concrete pavement away from the edge is found to be the lowest in comparison to the stresses due to same load applied at the edge and corner regions of the pavement. This is true because sufficient area is available to withstand the load applied on the interior of the slab compared to edge and as well as corner. Therefore, stresses induced at the interior is less, very less, compared to edge and corner. Okay. Repetition of loads. For design of rigid pavement, it is essential to consider, estimate the actual magnitude of heavier groups of axle or wheel loads, determine the flexural stresses developed due to these heavy loads, and estimate the number of repetitions of each load group to use the road during the design life. Because we must expect that the loads are applied on the road or pavement is repeated. Any number of times load applications is done on the pavement. Repeated application of high magnitudes of stresses due to cause of failure due to fatigue in cement concrete pavement structures. The plain cement concrete specimens or slabs can withstand against number of repetitions of load. Number of repetitions of load. The ratio of flexural stresses due to a load applied on a cement concrete pavement to its flexural strength is called the stress ratio. From the fatigue studies on cement concrete pavements, number of repetitions up to fatigue failure have been determined by using various values. Stress ratio between 0.45 to 0.9. This is while designing a cement concrete pavement, if stress ratio is less than 0.44, there is no possibility of fatigue failure. So that means if stress ratio is less than 0.44, there is no possibility of fatigue failure. That we have to take care. So this table shows the different values. So importance of design, load, etc. we will consider in the next lecture video class. Okay, thank you. Have a good day. Please keep in touch with studies. Okay.